I actually think that if we're going to do parsing, it might be easiest not to dive into compilers straight away. Some of you might want me to do, but to actually just take a simple, very simple subset of the English language and see how we would parse that. And if you look up in a dictionary, what does parsing mean? It says essentially one of the definitions is breaking up sentence structure into its component parts under the direction of a grammar. So the grammar is the rules of your language. Well, I have drawn up here a language involving furry dice and robots and people, men and women and cats and dogs, and they can bite, they can stroke, they can whatever. And I thought that little grammar, which I'll walk you through, is capable of generating between 200 and 300 sentences. And they are all valid English. But there's no way it captures the spirit of English. The idea that your sentences have subject, verb, object is pretty universal, I think, among what's called the Indo-European languages. However, sometimes it's not always in the order of subject, verb, object, although that's common. Sometimes they get twisted around, particularly in German, where there's a definite option to have the verb last. In this example I'm pointing to here, I'm using a notation that we did cover about 3 or 4 years ago now. We'll put out a link. I think the episode was called Angle Brackets. And they invented a notation that looks like this. Pointy brackets, yes. Back in the very late 50s and early 60s, people who wanted to write compilers realised they had to write down a formal specification of what were the rules in their language. And 2 computer scientists actually won the Turing Award, ACM Turing Award, for their notation and their development of a grammar for the language ALGOL 60. And it uses angle brackets all over the place. So that was so-called Bacchus-Nauer form. Those are the 2 computer scientists who developed it. People really liked it, and I've used it here because it's verbose enough to make some sense. I'll read it out to you. What I'm saying up at the top of the grammar, using the angle brackets for what's going to become parts of a so-called parse tree. A sentence is defined as a subject, then a verb, then an object. That's the most common form of English sentence. The subject is the personal thing doing the action, the verb says what the action is, kicked, bit, stroked, whatever. The object says what it is doing it to. The man kicked the robot. And it's such a powerful language. You can have either the or a, definite or indefinite article. You can have the robot or a robot. You can have a choice of verbs, either bit, kicked or stroked. You're going to be very expressive in this language. Your subject of the sentence can either be dog, cat, man, woman or robot. And finally the tailpiece, the object, I've decided can either be any article followed by a noun again, like a dog. The robot bit a dog, perfectly possible. But just to show that you can put in shortcuts, if you like, and put bits of structure in there that aren't parsed, they're just a globit that you can put in, I've defined the phrase 2 furry dice as being a valid object. Just the string 2 furry dice. So the target sentence that ultimately we're going to try and construct from all of this is the, lowercase, robot stroked. Running out of space here, carry on the line below. The robot stroked 2 furry dice. We all agree it makes sense. Is it parsable against that set of rules? And how would you go about showing that it was?
So by parsable, you mean, can we decode it?
Can we decode it? Can we assign everything to be the right flavour of structural component according to those rules? Now, you can either start with the string, which we've got here, and start trying to group things together and work upwards. Now, we all know about trees. The root is at the top. We're computer scientists. The root is at the top. The leaves are at the bottom. They're always upside down. Do we start with the leaves and say, oh, the robot stroked? Oh, the robot, I can, looking sideways at the grammar, I can see there's a shortcut for the robot. Shall I start coming from the string upwards and see if I end up back at the root of the tree? Or shall I start at the root of the tree and say I must have a subject, then a verb, then an object? Can I see anything that could likely be the start of a subject? That's called coming top down. So It's been there in computer science ever since the dawn of computer science, the top-down approach versus the bottom-up approach. There's no prizes for guessing that functional languages like Haskell tend, by their very structure, to favour the top-down approach. It's messier, is the bottom-up approach. I shall try and indicate both, okay? But let's just this once, let's go top-down rather than bottom-up. If we're coming top-down, it is telling me, is this grammar, that I must have a subj, then a verb, then an obj. Now, for those of you who are concerned with mechanistics, you can actually think of these things, if you're coming top-down, as being pushed as targets that you've got to satisfy on a stack, which we all know about stacks. This one is not building upwards and downwards, it's building from right to left. So at the top of my stack currently, because I'm coming top down, I say my target, my sub-target is subj. I must find a subj, but I must keep half an eye on the target string to say, does it really match? If we cross-refer now to this grammar for inspiration, we're trying to match a subject. If I look at the grammar over there, it tells me that a subject can either be an article and a noun, like the and a, with a noun like cat, dog, robot, or you can take a shortcut because it tells you here that a subject just could be the phrase the robot. So let's go for broke. I'm looking at the input string and I see the robot. So let's take the shortcut, just to be devils, right? I can say straight away then, taking the shortcut, that subject can be the string the robot. That's good. Now, having satisfied subj, I pop it off the top of my stack. I've done that. Next thing, to match this sentence, you've got to be able to match the verb. Well, we're going along the string. We've coped with the robot. Next word, next valid leaf word that has to match up with being a verb, I'm looking at stroked. Is stroked a possibility? Look at verb. What are the possibilities for verb? And I see bit, kicked or stroked. Great, I choose stroked. But once again, if you can imagine the stack, I then pop that off the top of the stack. We've done it. The stack is shrinking. All we've got left to identify is an object that matches that sentence. Again, I've pulled a fast one here. In the rules for object, I said you can either break it down into an article and noun, just like the subject, only it's having the action done to it, or you can take a whizzy shortcut. An allowed shortcut for an object is what you might call an object phrase, and I put it in deliberately just to make a point. 2 fairy dice. Wonderful. Simple. Par's going. An object can be 2 fairy dice. We declare success and we say we have matched the robot stroked 2 fairy dice by going subject, verb, object. Subject came down into being shortcut the robot, verb developed straight away into being stroked, object, shortcut to object phrase. It's a very shallow tree really, but it's developed the target sentence, the robot stroked 2 fairy dice. Now the only thing you might say, well yes, wonderful, we've parsed it, but would it have worked if for subject, instead of taking the robot shortcut, could you have done it with the article noun option? Yes, you could. I could have basically come here, let's write down subject, verb, object, and yes, right at the beginning, instead of taking the shortcut phrase, the robot, I could have said, but I'm going to do it as subject can be an article followed by a noun. So the head of the stack then would be, when we're looking at the sentence and starting off from the beginning again, it's got to be an article to start with. Article is at or the. Oh, I'm looking at the string, I see the. Bingo. So article can be the, no problem. Pop that off the stack. What's the next thing? What to look for? Noun. Can noun be robot, which is the next thing I'm looking at? Yes, robot is an option. So I could have done robot. Now the verb is as before, it's got to be stroked, and stroked is there, and equally the object is as before. There's only one way to develop the string 2 fairy dice, and that's to take the declared shortcut that does it for you. The reason for doing this rather artificial example is to say, oh dear, does this matter? We have got a sentence that makes perfect sense to us the robot stroked 2 fairy dice, but you've drawn 2 slightly different trees. First time you took the shortcut, subject phrase, just for the robot. Next time you said, oh, but we could also do it by breaking it down further into a the and a robot. Does that matter? In this particular case, in informal spoken English, no, it doesn't. If people understand you, the fact that your grammar is technically called ambiguous. So if you say to yourself, what does ambiguous mean? It means there's more than one parse tree that seems to satisfy and give the final target phrase. Does that matter? In this case, no. Does it matter in general? Yes. Because you might get very different effects under certain circumstances. What I think I'll show you is a favourite one almost, which is to check your 4-function desk calculator. When you start typing things into a 4-function so-called hand calculator, you're basically putting in, shall we say, integer numbers. Let's simplify it. But the burning question is something like this, that if you type in 8 star 4 star 2, you may not think of it in those terms, but computer scientists would say, yes, if you got the right grammar rules, that's an example of a sentence, in quotes. You know, that is a, what might you call it, a sort of subsection of a long calculation that you do on the right hand side of your C statement. It's just 8 times 4 times 2. There's no problem, is there? 8 4s are 32, 2 32s are 64. But then you say, but we're into tree structures now. How would you parse that sentence, given that multiply can only multiply 2 things at a time? So are you going to arrange it so that your overall expression groups as 8 times 4, done on the left, then you do the multiply by 2, which is that tree structure. So the question is, you've got a little bit of depth on your tree structure here. It's gone down a level, whereas finally you've got one up at the top level. Do you want that substructure to be on the left or on the right? Because it would be equally okay, as we've got things at the moment, for you to draw something that's got 8 here, multiplied by here, 4, 2, with a multiply between. So have we got a little bit of tree structure on the left or on the right, and does it matter? And you say, no, it doesn't matter. We all know that you can't complete the expression until its left operand is known, and that involves forcing you to do the multiply. 8 times 4 is 32, fine, 32. What's the other operand here? It's multiplied by 2, 32 2s, 64. Equally over here, 8 multiplied by 4 2s are 8, 8 8s are 64. So you're doing it 2 different ways, but you're getting the same answer. And the reason that's okay is that multiply is well behaved. Mathematicians will tell you it commutes. A times B is the same as B times A for integers. However, just look at but ambiguity. Okay, 2 different parse trees, and it didn't matter for multiply. Just suppose those multiplies weren't multiplies, but were divides. Does it then matter that you do 8 divided by 4 first in this one, which gets you 2, and the multiplies and the multiplies are divide? 2 divided by 2, 1. But look at this other possibility and just mentally substitute divides for multiplies. 8 divided by the result of 4 divided by 2. Well, 4 divided by 2 is 2. 8 divided by 2 is 4. 2 completely different answers. Is it 1 or is it 4? If you're panicking, take out your calculator now and check the app. Just do 8/4/2. And if the answer isn't 1, demand your money back. Here we see it then. Here is an example of where ambiguity does lead to problems, because depending which tree you choose, you get a different answer. So, there we are then. We now know what a grammar is. We know that against a grammar you can try and parse things like sentences, but sentences used in its wider sense, it could be a program statement from C. And just think of this 8 times 4 times 2 as being a part of a phrase on the right hand side of an arithmetic statement. And grammar is the guiding principle for the whole thing. Parallel work in America that they didn't know about had already got there ahead of them in many ways. I think some of their mathematical logician friends said, John, Peter, Are you aware that there's a man called Chomsky in the USA? He's a linguistics man, but very, very, very